Anybody want me to do number 2?
I think Stu told me what it was.
Okay. I'm gonna say I'm guilty here too. And you'll see it on the recording yesterday. I tried to get fancy, and then I blocked I blocked myself. Yeah, I know, it was pretty stupid, but
Been there, done that.
this really isn't that difficult if you understand where your formulas are coming from. So, here's the idea. Do you guys remember that this is some proportion of the cylinder, isn't it? How much of it is it? It's 1/3, right? So if we did something like this, if we took these 3 inches and kind of just transposed them over there, then we would have this much, correct? So imagine there's another cylinder in here that is 3 inches tall, right? Now, this liquid is still how much of that cylinder? It's still 1/3. So if I drop this and I fill in these other gaps, then what am I really doing? Once that volume or that level drops, what's happening to this 3 inches? I'm dividing it by 3, aren't I? Which means that it's only going to go up by 1 inch.
You said that was wrong, but I like.
Did I? Then I was
Here's
wrong.
Here's my question.
Then I'm my bad. I don't know why I would say that.
The cone that's 3 inches tall is the radius is smaller than what you're transferring over to the cylinder.
No, they're 2 identical cylinders.
No, you know, like the actual cone is, but the smaller cone, the 3-inch cone, if you were to transfer it over, the radius would be smaller than the actual cylinder, than the cylinder that doesn't change the radius. Because the lower you go on the cylinder, the smaller the radius is.
I see what you're saying.
Yeah.
I see what you're saying. And that makes a lot of sense too.
So I put a little less than 1 inch.
I would agree, because that makes perfect sense. But and you know, I did it mathematically as well. I still got 1, but that's assuming that the radiuses are the same, and they're still not. And I think that's what you'll hear in the video, is that the radiuses aren't the same, but it still is 1. And so this one's still a big. We'll leave that one as a big question mark still. And there was another answer that made a lot of sense too, but that it was less. It has to be less than 1. You're right. That makes sense. Okay. So, and I hope nobody really ripped their hair out here. That's not the point. The point is that you're thinking outside the box. Okay. All right. Cool. How about number 3? Anybody need number 3? That was the blocks of gold. Need the blocks of gold one?
Yeah.
Okay. Let's do this one. And I want to make sure we take our time here, because I'm starting to question a lot of these answers that are on the answer sheet. So please check my work. You guys need to be vigilant about that. Okay. So let me take number 3. Okay, cool. So here's what's happening. There's this dude, his name's Otto. The guy from The Simpsons. The bus driver, right? Wasn't that his name?
I don't know.
No Simpsons fans?
I did, but like, he doesn't have it in church.
Oh my god, I was a big Simpsons fan. Anyways, so Otto's sitting on 10 blocks of gold. The blocks are in the shape of a right trapezoidal prism. Okay? So that's what gives it away right here. Be very careful. When I first saw blocks of gold, I was thinking, like in the movies, how it has that kind of almost that candy bar shape, but it's beveled on all sides. Well, not in this case, because it's a right trapezoidal prism. So even though one of the faces will look like this, it's still at right angles. Okay? So they kind of look like, they look more like, you know, when you guys are driving, they have those blocks of cement. That's what they look more like. Okay? So anyways, we have, like what?
A trapezoidal.
It looks more like a trapezoidal prism. Yeah.
White blocks of cement.
You guys, you never been driving and they put those big blocks so you don't keep going into the store?
Yes.
It's for parking.
What are they called?
I don't know.
The parking lot block?
Blocks of cement. Those blocks of cement. Anyways,
So you don't
so So what?
The ones that we jump on as a kid.
And then try to make it to the other one? All right, so we have a trapezoid. The base of the prisms, the bases of trapezoid base of prism has bases of 10 inches and 7 inches with a height of 8 inches. So it expands for 8 inches. No, it's a height, my bad. This is still talking about the base. It's still talking about the base. So that means from here to here is 8. And then we've got a lateral edge of how much? 19? Okay. So there's your lateral. Upon how many cubic inches of gold is he sitting on? So what we need to do is find the area of the base and then just multiply by the height.
And then times it by 10. Because he's sitting on 10 blocks.
Well, not yet, because we still have, yeah. You jumped ahead of me. Good. So we need to find the area of the base multiplied by the height. That'll give us the volume of one of them. And because he is sitting on 10 of those, like I pointed out, then we're going to have a volume of...
Wait, what did you call me? Holly.
I didn't say anything.
Holly.
No, I didn't say your name.
You're like, you said something and pointed out.
Like she just hollered?
Oh, okay.
Holler like, oh.
Oh, gotcha.
No, you're Riggs. I call you Riggs.
Yeah, well, I didn't know what you said.
Oh. Now, if you don't remember the formula for a trapezoid, what can you do with that bad boy?
I looked at what?
If you don't remember how to find the area of this,
You know, look it up.
well, you're not going to be able to, guys. Disclaimer: you will not get any formulas for AZ merit. You will not get any formulas for your Galileo test. So, if you don't remember the formula, which is 1/2 h times base 1 plus base 2, okay, that's the formula. Think about it. All it really is two triangles. And it's the sum of those two triangles, okay? That's where it comes from. So, 10 plus 7 is 17. So 17 times the height of 8. And then we're taking half of that, so I'm going to divide that. It goes 4. 4 times 17, that's 40 and 28, so 68. So that's the area of the base multiplied by the height of 19. Kick this old school. So how do you do with the fingers again?
Yep.
72?
Yeah.
2, 7, 54, and 7. 61. 0 place value, 8, 6, 2, 9. Bam! And this is, yeah, so then times 10, so we're just going to add a 0. So this is inches cubed. Sha? You guys double check my work here? Okay. Everyone cool with that? Now let's take a look at the next part. Part B says,
What? What is suspense?
which is Kool-Aid? No, it's more Gatorade. This is a fruit punch Gatorade.
Is it the one with the powder?
Yeah, I buy the powders. Yeah, it doesn't make sense to buy the bottles and pour that in there.
They're more
So,
expensive.
yeah, somebody else said it before. Determine the worth of Otto's gold based upon the gold pricing, and they sell it per troy pound. Per troy pound. So we have this information that follows. Okay? So what we have this, which is 12,920 inches cubed. And what we want to do is to convert that into troy pounds. So I'm going to have to multiply this by something to convert it. Now at the very beginning it says there are 1,728 cubic inches in 1 cubic foot. So these are cubic inches, correct? So I want to get rid of cubic inches, which is 1,728 in 1 cubic foot. Okay?
So you just divide by 1,728.
Right, now this is why. This is really a 1, isn't it? Under their denominator. And what is it that I'm trying to cancel out? Those inches cubed aren't, well, not cancel out, but trying to reduce or simplify, create 1. So it makes sense that it goes on the bottom. So if this is equivalent, now what have I really multiplied by? 1. I multiplied by 1. Okay? This is the idea. Think about this as being like 4 quarters to $1. Aren't those the same thing? 4 quarters and $1, same thing. So anything over itself is just 1. So am I really changing the numbers? No, I'm just changing kind of what it looks like. So it's still the same value, except it's going to be now at some point at troy pounds. Okay? So if that's my first conversion, then what's my next conversion? I still don't want feet, do I? Where do I want to be? Do I want to put feet on the bottom or feet on the top? Well, if I put it on the top, what's feet cubed times feet cubed? Feet to the 6th, and they're like, what? So it's going to go on the bottom, okay? So feet cubed, and what am I converting to? Pounds?
Yeah.
So pounds, so LBS, correct? And it says there are 1206.83 pounds in 1 cubic foot. Are you guys checking that real quick? Making sure I'm getting my numbers in there correctly?
No, I can't see it.
Says there are 1206.83 pounds of gold in 1 cubic foot. So there it is. And then finally, I want to get rid of pounds because I want to go to the troys. And it says that there are 0.82 pounds. So 0.82 pounds in 1 troy pound. Okay? So, here we go. 12920. That makes 1. That makes 1. That makes 1. So I've got this. Do I need to multiply by 1? No, I don't. Do I need to multiply by that 1206?
Yeah.
Definitely. So 1206.83. I don't need to multiply by 1, but I am left with troy pounds. So troy pounds. And I'm going to divide by, do I need to divide by 1? I do need to divide by 1728. I don't need to divide by 1, and I do need to divide by the 0.82. So there it is. That's a lot. Now here's the thing, does that make us done? No, because that's only how many troy pounds we have, don't we? I need to multiply by how much they're selling the troy pound. So I also need to add, let me move this troy pounds over. Multiply this by 13,067.76 dollars. I would be at dollars now, because technically I'd be canceling out troy pounds as well.
Wait, is that what you got when you multiply your divided over there?
Because they're at the top? Yeah.
Wait, that's what you think?
Huh?
Just keep going.
I'm just going to multiply those the top ones and divide by the bottom ones.
Oh, so that's that all together.
Yeah, that's what you would do mathematically. I mean, that's not the number you give somebody. 12, 9, 20 times 1206.83 times 13,067.76 divided by 1728 divided by 0.82. So here's what I've got. That is exponential notation, so it's times 10 to some power. But if you keep working with it, it has that number stored in memory, so you'll be fine. Just go ahead and hit divide. So 143797776.4. came out right. What the heck? When we did it yesterday, we didn't get that number, and it was the same numbers. Maybe my calculators. But that's the number right there. Oh, hold on.
Wait, maybe like I got a different answer on the calculator.
Do this times this times this, and then divide by this and that. Did you do it all in one line?
No, I like did the top and then I pushed like equal and then I divided by.
I see what you did. See, this is what we got yesterday.
Yeah, I got a good number too. But is it like 9,000? It's 9,668,960. Yeah, it's 9,668. I don't like it's really bad. I'm just like watching them. I'm like, hey.
Here's what I did. I multiplied. Try it for me real quick. This times this times this, and then divide by this number. Hit enter, then divide by that. Yeah. Yeah. So you're gonna do two division problems. Take the product of the top, divide by this number first, get a solution, and then divide by the 0.82, which is what I did. Why? Is it still being divided? So if I take 12 divided by 2, that's 6. And if I take 6 divided by 2, that's 3, right? Well, what's 12 divided by 4? You can do that. You're just separating the amount of math that you have to do. So you divide it by this one first, hit enter, then divide by 0.82, and then hit enter.
Then I got your answer. Oh yeah, that's.
I think it might have to do with the order of operations of what it's doing exactly. No, but you took the answer and you divided it by that product. No, the calculator is the thing that's being weird. What if, try it the way you did again, but this time, put the two products in parentheses. Okay? Put the denominator, yeah, put the two bottom ones in parentheses and see what happens there. So it has to be something with the math. We're all wrong. Okay. Oh, well, that's weird though, because if it's dividing, it should be divided by that product, which is still just a number. Awkward. Okay. Moving on. Anybody need number 4? Anybody? Somebody? Okay. Cool beans. Number 5.
Oh no.
5. All right. How about Pharaoh Khufu?
I mean, it'd be like the last.
The dog one.
The dog one. That one was cool. I hated it. I hate you. I mean, I like you. I'm gonna cut the dog for you.
Wait, what?
His eye.
It just looks.
Looks like a hamster eye, doesn't it?
Out there. It looks like right here.
All right, so here we go. Here it is. The county installed a metal pipe under the Jones' driveway to allow for drainage of runoff from the road. The pipe is a cylinder. Thank you.
You're welcome.
The pipe is a cylinder with a diameter of 2 feet. A diameter of 2 feet and a length of 20 feet. To stop their dog Skeeter, yay Skeeter, from running into the pipe, the Jones decided to build a square steel grate for the ends of the pipe. The grate contains 5 vertical pipes, 5 horizontal pipes, and 2 diagonal pipes, as shown. If the steel piping is sold by the foot, how many feet of steel piping do the Jones need to buy to build the 2 steel grates? Okay, so here's what. So we have this image right here, and all we know is that the diameter of the pipe pretty much is, what is it, 2? 2. So this is a diameter, correct? That is 2 feet. And how many of those do we? Well, we'll get one grate. So I've got 2 feet. So I'm gonna recreate that triangle. Is that cool with y'all?
Yeah.
So this is 2 feet, and this is a square. That means that when we cut that side, this creates a special triangle called a 45, 45, 90, doesn't it? Okay. But it's weird because I remember my 45, 45, 90. My 45, 45, 90. That's horrible. My 45, 45, 90 had 1, 1, radical 2, correct? You guys remember that? So the question is, okay, that's 1, 1. I used to call that my base, but here I don't know what x is now. And I need that length, don't I? Because that's pretty much like the master length for all the verticals and horizontals. Well, I know this is what the proportions of a 45, 45, 90 are. This one's bigger, obviously. So how long is that? Well, how can I find x, peeps? Starts with an R, ends with an HGeo.
Ratio?
Yeah, wow, good job, ratio. So 2 over x should be equal to radical 2 over 1. So that means that x radical 2 is equal to 2. Divide both sides by radical 2. And x happens to be, let's see here, let's rationalize it. Happens to be, so this becomes 2 radical 2 over 2, that's 1. So the length of x is radical 2. Right?
You know how confusing that was?
That didn't make sense? I'm sorry. What part should I explain? Don't say all of it. There's a certain part that you didn't make
I
sense.
don't understand the radical stuff. Like,
Well, that's just a number. It's not a nice number.
it's weird. Like, how am I?
Well, it's just, look, it's just a number. I know that x is radical 2, correct? Now, here's the thing. How many do I need of those radical 2's? I need 5 of them to go across, 5 of them to go up and down, so I need 10 of them. Yes?
Yeah.
No?
Yeah.
Saints?
Yep.
Okay.
I was just.
So I'm going to so that means that I'm going to get 10 radical 2 for all the verticals and all the horizontals. But I also need the 2 diagonals. But those were easy, right? What were the length of those? 2. So I need to add how much of this? 4. Well, there's 2 of them, sweetie. There's one going that way, one going this way. So here is one grate right there. That is one of the grates. Let's find that first, okay, before we double it. Is that cool with everybody? I'm going to go on my calculator, 10 square root of 2 plus 4. And guys, make sure you push forward so you get rid of that radical so it closes it. And that's going to give me 18.14. That's close enough. And I need 2 of them. So times 2. So we need this to be 36.28. So that means how much do I need? How many feet of this bars do I need? You guys seen the Holly Berry dance? You guys haven't seen the Holly Berry dance?
I thought you said how's it going, Daniel?
Yeah.
No. I got embarrassed. Right here, peeps. I did. I doubled it. Because this was 1 grade, correct? But they need to cap both sides? Yeah.
Did they give you another number besides the 2?
Was it relevant?
Why, I was just asking, what was it?
It was 20
For what?
for the length of the pipe.
The length of what?
Yeah, so here's what's happening. I think you guys have seen these before, right? They're the storm drain things. They have, like in your driveway, what they'll do is so here's your driveway. They'll put a big pipe in there. And then there's the other end is open over here as well type thing. So they're covering this with a steel grate.
I don't think I have this.
I don't know that.
Not everybody does, but like in the rural areas, they have a lot of that. Like where they have like little canals. Have you ever seen that?
Oh, yeah.
And then you'll see those under the driveways.
We have to put those
Okay.
on.
You guys know how to do that? So they have one for one side, one for the other. So does the length matter as far as the wire is concerned?
Because then it'll stick like this.
Grazie.
It will.
Dang, that's horrible.
Well, like,
Were you trying to be mean to him or what?
No, I was like, how was your test? And he's like,
Oh.
There's some like I didn't understand, so I was like, I don't know what to say.
Dude, you're not supposed to understand. Remember to preach that, bro.
yeah, bro.
Oh, that's not. Like, what is this shit?
It's not the answer that they have. I saw that too. I think it's wrong. What? Yes.
What are you talking about?
Cookies.
Yours
Because peanut butter is better with jelly.
Peanut butter is better with honey. Have you ever tried that?
Peanut butter is really good.
On Tuesdays and Thursdays. Alright, cool. Silent. Play-Doh, anybody? Play-Doh problem, anybody? I'm asking you. I don't want to spend time doing something that you already know how. So do you need the Play-Doh one? Okie dokes. Okie dokie, artichoke. Okay. This is going to picture really weird. Sure. Okay. So here's the deal. In class, they give you some modeling clay. And it's a cube of modeling clay. And one of the sides measures 5 inches. Okay? Now, that means that if we had that means the volume of this would be 5 to the third, correct? Or 5 inches to the third? 5 inches to the third cubed. Sorry, not 5 inches to the third. What the heck am I talking about? That doesn't even make sense. 5 inches cubed, so that gives you 125 inches cubed. So this is the volume of the cube. Yes? Now what they're saying is, you know what? You're going to make little spheres out of them. And the spheres need to have a diameter of 2 inches. Okay? So you're going to make a bunch of little spheres out of that, and they're going to have a diameter of 2. Okay? So if I want to find the volume of one of those spheres, and actually the question is, how many of these spheres can I make? How many of these spheres can I make? So what I need to do is I need to find the volume of one of them, don't I? And that happens to be 4/3 pi r cubed. Okay? Now the radius of this is simply going to, because it's volume. So you're going to have 3 dimensions at this point. Okay? Now here's what's cool about this one is that, what is my radius? It's just 1. So do I really even need r cubed here? No, this is the volume of one sphere. One sphere. So let's find out what that is as far as decimal-like approximation. So 4 times pi divided by 3. So 4 times 3.14. Do this. 4 times 314 divided by 3. Okay? Now nobody write this down because this is not going to be on the test, right?
Oh, that was sarcasm.
Yeah, that was insert sarcasm here. I see everyone just staring at it. I mean, unless you honestly know it, then that's cool too. I mean, I'm cool with that. Just don't be.
I got a 4.18.
I believe that.
Oh, yeah.
I believe that because 3 is going to almost cancel 3, right? So, is that what you said?
4.18.
Oh, 4.18?
186.
1/8 is cool. Okay. Woo! So here's the deal. I know that the cube of Play-Doh is 125 inches cubed. One sphere takes 4.18 inches cubed. How many of these can I make? What type of problem is this now? Division. Divide it. Divisiato. Origato, Mr. Roboto. Boom shakalaka. Razzle dazzle.
29 of them.
Huh? What'd you get?
29. Well, it's 29.9, but you can't make 30 because then you have like 0.9 of
Exactly. So your solution here should be 29. Because at the end you've got 0.9, which is not enough to make one more sphere.
That's a 5, right?
Huh?
B and then that's a 5, right?
That's S. V sub S. Volume of the sphere. Of the sphere. That's not very easy for me to say. That and statistics, even though I teach it, like statistics. I just say stats. Statistics. Yeah. I had one guy call it statistics. Statistics? Because it's painful. Because it's painful to do.
Numbers in German. Oh, you
What? You know German numbers? Why? Why would you know numbers in German?
So you go to Germany. I was Jack can teach you how to speak French. Yeah.
I learned my numbers in German so I can speak French.
No, I was saying something else. I said I was just Googling how to speak French.
Oh. You know how you count in French, right? It's one, two, three. I don't know. Four.
It's like really similar to
The French is?
No, I don't remember, bro. He like tried teaching me. It's like, I know how to say it. So 6.
I had a German ornament student. What's her name? Yeah, and I asked her how you say hello, and she says, hello.
That's what.
I'm like, what? No.
Yeah, she's on my son's.
Oh, cool beans. Oh, yeah.
On your dance class. Where's she from?
Germany. Okay, Play-Doh problem's good? How about peanut butter jelly time? No peanut butter? 10? Yes, on 10? Okay, cool beans. This one was actually a little bit time consuming. It was just more, it wasn't hard.
Like some of those you can look at it and like, oh, that's true.
Right.
The other one's like, oh, great.
I gotta do math. I gotta math. What? Alright, cool. So, let's do this. I'm going to, I don't want to copy all that over. I'm just going to. Peanut butter jelly, peanut butter jelly. So, a manufacturing firm hired a company to design a pyramid-shaped container shown at the right. It was discovered that certain specifics regarding the design are incorrect. Oh, you would have been fired. If you had been hired to find the errors, the pyramid-shaped container is a right square. Someone pointed out that that was redundant. Container is a right square pyramid with a base side length of 6 inches and a height of 9 inches. In the diagram, G is the midpoint of AD. Which of the following statements are true regarding the drawing of this container? Choose all that apply. So the first one says GF, and I'm sure that they meant to say segment. GF is equal to segment FD. So where's GF? Here's GF. It's the red broken line to FD. Is that true? No. Okay. Technically, FD would become a hypotenuse there. This would be a right angle. That would be a hypotenuse, so this is not true. No, no, no.
It means a pyramid-shaped container.
Huh?
What would you use a pyramid-shaped container?
I don't know. Don't they have one in Paris, kind of like that? It's made of glass. Remember the one from Da Vinci Code? The
They're
Lou?
talking about-
The Lou? Is that what it's called? Something like Lou, Blau, Louvet? All right, cool. Is the volume 108 inches cubed? So we're going to treat this like a rectangular prism and then take a third of it. So area of the base, 6 times 6 is 36. Multiplied by the height of, and how much of it do I need? Rocky Toto Tan? How much of it do I need? We're finding the volume of this thing. So I want only a third of it. So 3 goes into 36 13 times. 90 plus 27 is 108. So this one is true. Right? Then number 3 says triangle EFD is a right triangle. EFD. That is true as well. Okay? It's going to be one that uses the edges here. So this one is true. Then it says GF is 3 inches. GF is 3 inches. That is true as well. 5 says segment ED is 3 radical 11. And ED is this edge again, guys. So from E to D. So to find that, well, we just said that that was a right triangle, didn't we?
Yeah.
So if we have a triangle with 9, we'd have to find this first, wouldn't we? Okay? So if we have 3, 3 for this one, you guys see that? So if we went 3 squared plus 3 squared equals, we'll call it h. Is that cool with everybody? H squared. I've got 9 plus 9. So 18 is h squared. Take the square root of both sides. That should give me 3 radical what? 2. So this is 3 radical 2. So now I could do the other one, which is one side and the other side. So 9 squared plus 3 radical 2 squared should give me what I'm looking for squared. So 81 plus 9 radical 4. Square root of 4 is how much? 2. So this is 18. Cool? So 18 equals h squared. Oh, that's funny. So what's 81 plus 18? 90, 99? Why did I say 18 squared? So 90 what? 99 equals h squared. Square root both sides. H is square root of 90. And then to find that, we can just use our upside down cake. You guys ever use upside down cake? Or inverted division? I don't know what you've... Okay. Here, let me do it over here. Just because this has more space. So 99, I could divide by 3. I'm going to get 33. Divide by 3, I get 11. So this should be 3 square root of 11. So true.
Miss Charles tried teaching this in 6th grade. I just did. She tried teaching you guys this? Yeah, I was like, whatever.
What happened?
The whole upside down thingy.
You guys never done prime factorization?
6th grade.
You guys probably did with trees?
We did, yeah.
You remember
Little
it?
trees things? I like this one because it keeps it cleaner. Because here's what I always did, like sort of got with my little trees. I would always end up like some number, and then I'd break it right into the prime or something, and then I'd have another number. And you're supposed to do this, aren't you? Kind of thing. But then I'd like, oh man, and I'm like, I'm everywhere. Right? You guys ever do that? Like, man.
I do that every day.
So now I just use the upside down cake. So I start with my number, and I divide. So 3, that gives me 33. And if I can keep it, because it just goes in there, it's a prime number. I always start with 2, but this is not obviously divisible by 2. So then I'll go to 3. And if 3 doesn't work, then I'll go to 5. 5 doesn't work, then I go to 7. Okay? And then I'll just keep going. So for every 2 that I've got, I know that 1 comes out. So I've got 3 square root of 11. Do you understand that idea? Let me say more. The square root of 99 is equivalent to saying, hey, that is 3 times 3 times 11. Does that make sense? Okay. Now, I can also rewrite these, if I wanted to, as the square root of 3 times the square root of 3 times the square root of 11. Same thing. Okay, this is all radical notation. Okay? We're good? Now, I could also say, you know what? This is just the square root of 9 times the square root of 11. And I know that the square root of 9 happens to be 3. So what I've learned to tell my students is, when you're doing your upside down cake, if this is the square root, then for every 2 you have, one's going to end up on the outside anyway. And then whatever's left over stays inside.
What if like the number's different? Like what if one's 3 and one's different?
Then you don't take them out. So you're saying maybe I was able to go further and I had like a 4 and a 2.
Yeah.
Then 4 times 2 is 6, and that would stay inside as 6.
Wait, why would that be?
Oh, sorry, 8. Because I don't know how to multiply.
Well, I mean, like, but why would that be inside of it?
Because technically this is your breakdown. What you're doing is you're taking a prime number and you're breaking it down. So here's what would happen. You'd have something like that. Here, give me a number.
48.
48? Oh, that's kind of nice.
72.
72 is a little grosser. Let's try 72. So let's say I had 72. I'm starting with that. What's the 72 divided by 2? 36?
Yeah.
Okay, so 36. Well, that's just kind of nice because it's 6 and 6, isn't it? So what would happen is I've got 2 the same. So here's what I'm saying. I'm saying that the square root of 72, is the same as the square root of 2 times 6 times 6. So what I would do is say, oh, you know what? I've got 2 coming outside, which is 6, and then whatever's left inside. So whatever's inside still gets multiplied again. So if you had a 3 in there, then 2 times 3 would give you 6 inside.
Was it there like some rule like
Wait,
to
don't
add,
do it.
like to add numbers and subtract them?
Yeah. And the rule changes is if you're adding them, then they're just like variables. They stay the same. But then the rule changes if you're doing the cube root. If it's a cube root, then you're not looking for... So let me treat this as if this was the cube root, okay? So I'll do this in blue. So this is the cube root. So here's what I'm looking for. Not the square root of 72, but the cube root of 72. Okay? So then I would go about the same upside down cake. So 72. And I can divide by 2. That would give me, what do we say, 36? I can divide by 2. That would give me, what is it, 17? 18, thank you. Divide by 2, that would give me 9. Divide by 3, that would give me 3. So in this case, because it's the cube root, I'm not circling pairs anymore. This time I would be circling in 3s. Because why would I circle them in 3s? It's a cubed root. So 2 would come outside, and I would have 2 radical 9.
But you're circling ones that are the same, right?
Right,
Okay.
right, because then that would be the cube root of that. Because technically you'd have 8, wouldn't you?
Yeah.
And what is the cube root of 8?
Okay, yeah.
Catch that? Cool beans. Important to know.
What's that noise? Is there a bomb in here?
Yes. Me, because I'm the bomb.
Bomb. I like you said mom and then you said me and I was like, wait, what?
This sounds so awesome.
I said bomb.
I know, but she's not. I know.
Alright, cool. Let's finish this one. Number 6. The area of EDC. EDC. So we're looking for the area of this face. So base. Ooh, that is nice. Because we need the height, don't we? We need the height here. So, ideas?
Oh, I remember now. I remember how I did this.
What'd you do?
Okay, so I think it's EFG, the triangle that's like kind of in it, right?
Oh, wait a minute. I know how.
Yeah, and you find the hypotenuse, so you could see the lateral edge, and then you split the face triangle in half, and then you do the Pythagorean theorem and find the height.
Yeah, because here's what, yeah, that's exactly right. Because you'd have to go here. So that would be, oh, I took away the, the writing portion of it. Come back to me. Okay, so if we extend this to here, then technically this would be the height we're looking for, which is the hypotenuse. So we've got 9 squared plus 3 squared equals that hypotenuse squared. So we've got 81 plus 9, correct? So that's 99 again? No, that's 90. So 90, we need to find the square root, so divide by 2, that's 45. Can I divide by 2? No, but I can divide by 3. That's 15. Divide by 3, that's 5. So here's a good example of what you were asking. So I've got the 2 3's, don't I? That comes outside. Root 10, exactly. Cool. So there's my height. I want to multiply by the base of 6 and divide by 2. 2 goes in here 3 times. 3 times 3 is 9. So the, oh, no, that's wrong. Can you multiply that out? It's actually a little bit more than that because what's this, the closest square root I know of is 9, right? And that's 9 times, so that would be 3. 9 times 3 is 27, but it would be higher than that. So this says equal. I would say no, that's not correct.
How'd you get to 3 though?
Well, they told us that this was a midpoint, right? So then if I go down to the midpoint here, then that would give me 3 and 3 for 6. Okay? So I would have to say that this one is a no-no.
Wait, but like, how'd you? Because aren't you trying to find like the blue triangle, right?
No. I only use the blue triangle to get this height, this slant height, which is a height.
Didn't you use a 3 to find that height?
Yeah, because this is also 3. Remember, this is square at the bottom. So this is 3, this is 3, this is 3, this is 3. It's 3 everywhere pretty much. Okay. The last one. That says congruent. So let's see here. EDC. Everyday carry. EDC. Congruent to EAD. EAD. That's true. It's just 2 faces of the triangle. Cool. Woo! All right. Watch out. Cool beans.
You did that this morning when you were walking in the door. You screamed.
Yeah, I'm trying to get pumped.
It scared me.
Woo!
I'm okay.
Where's your mind back to one? You guys see that, right?
Yeah. But like,
want to jump up and dance? Okay. Are we good? Yeah. Bye-bye, worksheet. How are we on time? Oh. Man, we got through this quick. Great.
Wait, do we do number 7?
Did we do number 7?
That was 7.
Which one was 7?
On number 10.
Yeah, we did all of them.
What was it false?
No, that's true. It's the face that's right here on the triangle, this one, compared to this face right here. Well, those two faces are the same.
Are they?
Yeah.
Oh, because
Are they?
yeah, I got that.
It's two faces of the triangle, of the pyramid. It's not slanted pyramid. It's not a center pyramid. It's the same thing. Okay, cool. Your favorite one. This one wasn't so bad, yeah? What did number 1 create? Number 2. 3. 4. 5. 6. A frustrum. It's called a frustrum. Because it makes you frustrated.
That's what I said. That's what Steele was telling me. He was like, he's like, that's not what it's called.
It's a frustrum.
I was like, stop. I'm like, make it a colon. He was like, no, it's not.
What did 7 create? What did this create?
A cone, right?
It was like a cylinder with a cone cut out of it.
Wait.
I'm not sure if that even...
I put cone. We put cone.
Huh?
Oh wait, I see it. It's a cone. It
That-
goes in about y equals 2.
Yeah, y equals 2. Y equals 2 is right here.
Yeah, so it's a cone. It's a cone.
Oh, it's flipped this. Oh. Still a cone.
Still a cone.
Sure, you're right. It's a cone. It's a cone. Cone, cone, cone. Okay, so you were supposed to find the volume of those above. And then for the bottom, you're trying to sketch what they were. So this one,
It's like a
cone.
Wait, I did
No.
sketch it.
Mr. Munoz, I didn't sketch it, but I said that they would create. Yeah,
I got this thing.
It's like a diamond, but with like a circle.
Ooh,
Yeah, it's like a diamond.
that's beautiful.
Like
It's like a diamond, like a top almost, huh?
I said like spinning. Oh, I just read it.
What did this create?
Like the chores.
It was a torus with no
With no hole.
holes.
So like jelly filled donut. That's what it reminds me of.
Yummy. This was
Like a pipe. It's like an empty cylinder. And then 12 was an egg.
and then this one.
I said it was a watermelon.
I said it was a.
I said it was a watermelon.
This is green.
What's it called?
It's a
Is it a football?
And it's like I mean,
Kind of.
huh.
a rounded football.
I don't know what it's called. I was like a really oddly shaped football. It's called an oval, guys.
I would have called it that. Let's find a name for it real quick.
Wait, wouldn't 11 be like that donut shaped thing? Like
A really long one though. It's kind of like a pipe almost.
Yeah, but it's still torus, isn't it?
Wait, 11?
No, it's not. I wouldn't call it torus because torus is round all the way. This one is actually more cylinder-like, kind of like a cup. When you look at the inside of it, but it has a flat top, while the torus does not.
Wait.
What do you call that?
I call it a pipe. But let's find out. Let's find some names for those. Let's see here. Math name for an egg shape.
Watch it just be an egg shape.
Oh, it's an oval.
I even put oval in there. I think that was even a little.
No, wait a minute. That, I think it's giving me it's giving me 2D for a
3D egg shape.
right 3D egg shape.
ED, you put ED.
ED.
Here we go.
A 3D oval.
What is the name of a 3D oval?
It's an ellipsoid. No, that can't be it. Oh, it is. It's an ellipsoid. Ellipsoid.
Ellipsoid. Oh, I think I've heard of that before.
An ellipsoid.
This is so much more than this. It's probably weird. It's like the same. Well, they like so much this. Or
Here we go.
it's like a tree.
Yeah, it's an ellipsoid. Oh, this is a cuboid. It's not a right rectangular prism. It's a cuboid. Sounds like a video game of some sort.
Yeah, right. No,
Have you played Cubert?
it's big on me.
It's actually pretty lame.
That's backwards.
Yeah.
What?
The words are backwards.
Yeah.
Someone took a picture of the back of the paper.
That's like what you use in kindergarten.
I'm not healthy at all. I eat so horribly.
That one.
When it was my birthday, my mom made a cake and like I put it in the freezer so I wouldn't eat it out eat it like every day.
Whoa. Is that like at a jewelry store? That kind of jewelry store? Bless you. Bless you.
Thank you, thank you. Oh, that was only 2.